Hello and welcome back to my series on smarter, more adaptive manufacturing. And today is going to be the first of a two-part series where we're going to be talking about money and finance. Now, finance, the finance calculations that the finance department use and pass on to the procurement teams aren't fit for purpose anymore. And so even if production knows what they want and engineering can deliver it for them, it quite often fails because from the finance department it's a no. So this is incredibly important. This is the reason why over 90% of projects or initiatives, smarter manufacturing initiatives is a better term, fail. And it's on the finance. So the first part of the two series is going to be on putting a real value on flexibility. Now, everybody uses the term flexibility. They have done for many years, but no one I've asked ever has given me a definitive definition of what value flexibility brings. So, as I mentioned in my previous episode, I have done a computer simulation of 5 lines, and I'm really proving the value of those 5 lines moving towards being able to make all products on all lines. And in the second part, I'll be talking about the benefit, total cost of ownership and the total benefit of ownership. This is something I've talked about many, many times. And so I've put it in a graphical way. This is not a course on finance, but what this is a 101 course on the tools that you need to enable smarter manufacturing. Without it, you will probably fail. So let's get straight into it. This is why I use the term adaptive manufacturing, because adaptive is much more descriptive. What we're really talking about is asset utilization. All right. So in this simulation that I'm going to show you the results of, and I will probably publish the code. It's AI helped me write the code, but it gave me some fantastic results. So if I talk to you a little bit about these simulations, because this is important. So at the bottom here, you see the traditional line. Okay, so this is copied and pasted across the land. And then we've got what I would call class 1 adaptive manufacturing, where some of the function modules can be plugged into a transportation system. There's an incredible amount of advantages, so I'm not going to go through them all again. But what I'm trying to convey here is, in simple terms, in an isolated way, just for the primary packaging lines, is making all the products on all your lines or cells. Okay, so if you go into any factory around the world, there's always outliers. Okay, so out of 5 lines in this particular one, we've got these parameters, which I'll show you down here in a minute. But class 2, which is about as high as it gets at the moment. There is another level, but we're really not there, because I would say less than 0.5% of manufacturers are anywhere near this level that you can see up here, this level of adaptation. Okay, so back to where we're heading for today's conversation. This is the parameters of the simulation. Now, I did a simple simulation to start off with, but I've done a more complex one since. So I'm going to zoom in a bit so you can see it. I know most of you watch it on your phones. So in this particular, you can see the parameters of the line, all right? These are the product types that we can run on the 5 lines. And the maximum output in this case is 6 million units for every 3 months of every quarter. And importantly, when I went to a more complex model, a more complex simulation, you can see over here that it creates a class with the product range, maximum hours, change over time. This is hugely important. Quality performance, CIP time, and downtime a week. Now, the downtime is a bit of a finger in the air, but the important ones here really. Quality I've kept the same because there was no need to add another factor, but it's there and I could add more. Okay, so these are the parameters here, and I've run this time and time again, 12-week simulation, and what happens every time and this is where we start to put it into monetary terms, what happens every time is the repeat orders or the rollover orders, and what always happens is it gradually creeps up. So it will randomly generate orders within a range of sizes and the product types. So this really stresses our factory, our simulated factory. So you can see here that the asset utilization is normally between 40 and 60. And what this, you can see how painful this gets from a management point of view, an overhead point of view. And the more SKUs you add, I've only got 20 products. And as you add product families and different types of products, this only gets worse. Also, one of the other big things with adaptive manufacturing and how it changes and gives us a huge advantage is how it behaves in unplanned events. So downtime is a huge thing. So on the traditional serial cascaded line, anything happens on that line, it impacts downstream and upstream. And when you've got a very a complex process upstream, you have to shut it down. That's expensive. So the simulation doesn't account for all that. It can do. I may expand it in the future. But this is where it gets interesting, all right? And this isn't me tweaking the numbers. Like I said, I deliberately made a lot of the inputs random. So what I've done here is I've changed some of the parameters. You can see here the changeover times come down. So this is, but what I've done here, you can see, is, so the simulation is running in, I would say, so 3 of the lines, for example, can run all products, but the others still have a range of products. And what we tend to get in these situations over here is basically we get a higher throughput generally. So we're in the 70s now, generally, late 60s, 70%. So this is total asset utilization. And you can see here from the graph that, yes, the unfulfilled orders gradually creeps up, but it can recover. And if you run this again and again, what tends to happen is you get a peak and it recovers and it recovers. So our trajectory isn't always up. And this is a huge difference in how the model and how the manufacturing line behaves. Okay, so if we come up here, this is I call it class 2. So this is fully adaptive. We can run all products on all lines. This is the key. This is really how we define flexibility. All right, the changeover time is drastically reduced. CIP time is drastically reduced. When I say CIP, what I really mean is the modules can be cleaned out of place in a CIP station, if that makes sense. So we don't have to do any cleaning on the line. All right, so we can have spare modules, even if we have a fault with a module. It might be quite a complex module. It doesn't matter. It can be disconnected, reconnected, and the cell restarted. So generally, when we go up to here, we're getting late 70s, mid to late 70s, and even 80s. You can see this simulation here at the bottom was a very busy 3 months for this manufacturer. And you can see the rollover orders going up, but then it recovers. And then on a not so busy week where the total production was slightly lower, we've actually had 0 rollover of orders. And so what this generally means is you need less lines. Of course, what happens with the traditional lines is as you add more products, you generally add more lines or cells, have to buy new equipment, etc. But as soon as you split out in a truly modular way, this is the key to what this class 2 adaptive diagram is showing here, you can deal with all these standard issues that you traditionally get. And the list is long. I can't even list all the benefits. I've got some of them listed here. So this is the simulation here. So this is just 5 cells, and we've got the process cell upstream. We've got secondary packaging if we need it, or bulk case packing, as you can see there. And importantly, when we start disconnecting our assets, decoupling our assets, and using AGVs, AMRs more, we can have more planned work in progress. All right, it could be for any reason. I've said this many times before. But once you split your cells out, you've got much more freedom to route product to different areas. So we've got custom packaging cell. All right, so that could be where we're getting lower to MOQ1, a lot size 1. We've got mixed case packaging, which could be going off to distribution centres or whatever. But the point is that the factory can do everything. We don't have to have any intermediate unpacking and repacking of products. This is why I don't separate adaptive logistics from adaptive manufacturing. So the outcome of this is the main topic, and this isn't all the advantages. I actually haven't bothered. So we've got an extra 20% off the bat, so of asset utilization, which in this case equates to 1.2 million units a quarter. And so we have significantly lower rollover unfulfilled orders, which I've explained. And the cost of adding new SKUs, new materials, plummets, because we're not creating another machine. We're buying modules to adapt to this existing asset. Okay, so we're much leaner with how we deal with our money. So just to conclude this part 1, what we've really covered today is trying to pull apart the true value of flexibility over a longer time period. And I think it speaks for itself when you really concentrate on the critical factors of change over time, running all products on all lines, and reducing downtime, but being able to produce planned work in progress. The benefits speak for themselves. So hopefully you found that interesting. I look forward to seeing you on the second part, where we're talking more about the longer term elements of this. So bye for now.